Hello guys, let's solve one problem from AMS competition. And problem is following. If you have expression 10 to the power 10 plus 10 to the power 100 plus all the way until we reach 10 to the power, and then we will have 1 and 10 zeros after it. We wanna know what is a residuum when we divide this number by 7. So actually we are looking for x such that this expression is congruent to x modulo 7. How will we approach this problem? First thing we could try is to divide 10 to the power 10 by 7. So when you divide 10 to the power 10 by 7, you will get residuum is equal to 4, which means that 10 to the power 10 is congruent to 4 modulo 7. Then we will use 10 to the power 10 to find what is 10 to the power 100. So we know that 10 to the power 100 can be written as 10 to the power 10, everything to the power 10. And we already proved that 10 to the power 10 is 4. So this is actually 4 to the power 10. So if we divide now 4 to the power 10 by 7, we will get that the residuum is 4 in this case as well. You can check that using your calculator. So this tells us that 10 to the power 100 is also congruent to 4 modulo 7. Okay, so what about following number? In this sum, this is 10 to 1000, and again I can use 10 to 100 to the base, and to the 10 to the 100, sorry, to the power 10. And again I got 4 to the power 10, so that will give me 4 modulo 7, which means that all of these numbers in the sum are 4 modulo 7. So this means that my number x is actually 4 plus 4 plus and so on, 4 in the end. How many 4s do we have here? We will check that by counting number of zeros in this numbers or exponents. So here is 1 0, so this is first member. Here is 2 zeros, so this is second member. And in the last number we have 10 zeros, so that will be 10th member. So that tells us that we have 10 times number 4. This means it is 40. Last step, we divide 40 by 7. We get remainder is 4. Remainder is 5, because 7 times 5 is 35, so 40 minus 35 is 5. So that tells us that x is 5 modulo 7, which means that our number divided by 7 is gives a remainder 5. That's all. See you soon.